Hello everyone, in this video we're going to go over section 9.6 and R combinations with repetitions. So first let's talk about multisets. So think about this question. How many ways can we choose R element from n categories if the same element can be chosen multiple times and order does not matter? So an R combination with repetition allowed, or multisets of size R, it gives me a set x1 to xn, and then an order selection of our elements where repetitions from x is allowed. So one example of that would be, consider the set of 1, 2, 3, 4, and we're going to write three combinations where we're allowing repetition from the numbers. So that will give me elements like it follows. Like we'll have like 1, 1, 1, 1, 1, 2, 1, 1, 3, 1, 1, 4. Then we'll go to 1, 2, 2, 1, 2, 3, 1, 2, 4, 1, 3, 3, 1, 3, 4, 1, 4, 4, so on and so forth. So as you can see, we have repetitions of an element twice and even three times. And we have all the possible combinations that are possible. Now here we get a total of 20 multisets of this type of combinations. Now, to be able to count that, we're going to include something that we call the stars and bars formula. The key idea is that we represent a selection as a string of R stars with this symbol, this X here, representing the stars, separated by m minus 1 bars, dividing the n categories. So something like selecting 15 soft drink cans from 5 types, it will give me a strings like this. So we'll have 3 on the first bin, then we separate 1 bar. Second category we'll have 7, then we'll separate the 1 bar. We have nothing on the third category, we separate with 1 bar. And then we have 3 on the next category, separate with 1 bar, and then we have 2 more. This means 3 of type 1, 7 of type 2, 0 of type 3, 3 of type 4, and 2 of type 5. The total symbol here can be given by R plus n minus 1, which in this case will be 15 plus 4. 5 minus 1, right? So this will be a total of 19. And we choose which positions are going to be the stars. So in general here, we will have, out of the 19, we're picking 15. Notice that in general, the combinations with repetitions can be seen in 2 ways. We can see it as we're picking R plus n minus 1 out of R, or R out of R plus n minus 1, or we picking n minus 1 out of R plus n minus 1. These two things are going to be equivalent if you do the combination with factorials. If you check the formulas in factorials, this is going to be exactly the same. Okay, so now let's take a look at the soft drink examples again. So we're selecting 5 types of soft drink out of 15 cans. So the total selection is, we're picking out 15 out of 15 plus 5 minus 1, or 19. So we're picking 15 out of 19, which is going to be the same as picking 4 out of 19. So this in total is going to be 3,876. Let's say at least 6 cans of root beer. So in here, we will be fixing 6 root beer. So now we're not picking 15, but we're just picking 9. So we're going to remove those 6 out of the total, but we're going to remove those 6 out of the selection too. So now we're doing 9 plus 5 minus 1 and choose 9 out of those. So we'll be picking 9 out of 13, or we're picking 4 out of 13, which in this case is 715. We can also do at most 5 cans of root beer. So this is like the store only has 5. So instead, we'll be using the complement of that. So from the total of selection, we're going to subtract the possibility that it's more than that at least 6. And so the way that we do that is we do the subtraction from the total minus the 715 that we got from the at least 6 kind of beer. And that's going to give us the total here. So notice that the key idea with this, with the stars and bar method, is that I got to select, I got to identify who's R, who's N. And once that I do, then I got to decide what formula am I going to use. Notice that we have the 5 types in there. And so 15 out of 15 is going to be or R in this case, which is representing the string of selection that we're picking, and the 5 types are going to be the N. So is different from the usual combination that we do. Normally, before we would have that R was going to be less than N for normal combinations, but when we're doing repetition, R can actually be the larger number here, and N is usually the type of category that we're picking. So usually it's much more smaller than R. Okay, so now let's talk about integral solutions of equations. In here, the stars and bars directly is going to count the non-negative integer solutions to equation of the form x1 plus x2 up to xn equals r. So what happened is we're going to think of each variable as a category and each unit as an item to distribute. So for example, we have here x1 up to xn equals r. So we're essentially having that this is giving me n, and this is going to give me r in the equation. And it's going to have r plus n minus 1 combine our solution with xi bigger than 0. So as an example, if we go with x1 plus x2 plus x3 equals 7, then of course r is going to be equals 7, n is going to be equals 3, and then we can plug that in the formula. We're going to get 7 plus 3 minus 1 combine 7, which is 9 combine 7, or 9 combine 2 is going to be the same. And that's going to give me 36 solutions. And so that's for xi bigger than 0. But you can think about, well, what happens if x is bigger than 1? Xi is bigger than 1. Well, what we got to do is we're going to rewrite the equation in a way that it becomes a new variable, but it's bigger than 0. So we can write a new variable yi, being xi minus 1. So that becomes bigger than 0. Since xi is bigger than 1, xi minus 1 becomes bigger than 0. And instead, this equation here, notice it will be y1, y2, y3 equals 4. Notice that to get this 4, we're getting y1, y2, y3, but our original equation was x1 plus x2 plus x3. So to convert this equation on this one, we need to subtract 1 from each of this. And so this is going to subtract 3 out of 7, so it becomes 4. So that's the reason why this equation transforms into y1 plus y2 plus y3 equals 4. Because we're subtracting 1 from each of this to transform this into y1, y2, y3. And now this is our new r. Okay? All right, so in summary, R combination with repetition, you're choosing R items from n categories, but the repetition is allowed, the ordering is ignored. We have the stars and bar methods to encode each selection as a string of R start and n minus 1 bars. And the formula is R plus n minus 1, choose R, which can be equivalent to the R plus n minus 1, choose n minus 1. We can also combine with complements different rules for restrict selection, at least k or at most k kind of type of solutions. And the integral solutions x1 plus up to xn equals r with xi bigger than 0 is going to have r plus n minus 1 choose r solutions. If you shift by 1, then instead you can change the variables that you're using. If you need to shift everything a certain amount of numbers. Now, common mistakes to avoid. You gotta be careful of using and choose R instead of and plus R minus 1 combine R. And choose R applies when there is no repetition. When repetition is allowed, you gotta use R plus N minus 1 choose R. You gotta be careful not confusing N and R. N is the number of types and categories, and R is the number of items to select. You also need to be careful of not forgetting to use the complement for constraints. The at least K type, you got a fixed K of type X and then count freely. And the at most K type of X is total minus K plus 1 more of type X, that kind of situation. So make sure to check on the class notes exercises for more examples of this. But next we're gonna go to the Pascal formula and the binomial theorem.